Okay, hello party people. This is my tiny microphone. And I'm Delaney, and today I will be explaining spaghettification while making spaghetti. I already have the pot going with some noodles in it, so I'm just going to go ahead and start explaining. Reminder, disclaimer, I don't think this video is going to be between 2 to 3 minutes. I have a unique ability to not shut up, so sorry, Professor Madigan, in advance. Hope you like it. Hope you have fun the way I'm having fun. Spaghettification. To you, this may look like ordinary piece of spaghetti, whole wheat spaghetti. But what this is actually meant to represent is when an object gets too close to a black hole. Now let's start explaining. What is a black hole? So, imagine a star dies, and it goes off in a big explosion called a supernova. I'll put the link for an explanation for what a supernova is down below. And essentially, a big explosion. Huge explosion. So, you have all this material flying out, and then it compacts into a tiny, tiny little dense point. And when you have a lot of matter in a very small volume, making it extremely dense, which is what makes black holes so unique, what happens is that you now have extreme gravity. Now, we get into spaghettification. So, spaghettification is caused actually by the extreme gravity of the black hole, but even more so. Sorry, I think my pot is boiling over. Pause. Tidal forces technically is not just gravity, but rather gravitational difference. So when you have extreme gravity on this side, and not a whole lot on this side the way this side is, this part gets squeezed. Okay, where was I? So, tidal force. It's the gravitational difference that does it. So you don't have a lot of gravity on this end, and then you have a lot of gravity on this end. So it starts to kind of like splay out, right? But the middle gets squeezed. So as it's splaying out, it's also getting thinner. So when you get thinner and you start to roll out a little bit, what does that look like? Spaghetti. It looks like spaghetti. Now we just need to make the sauce. Vodka sauce. We're getting crunk. Ooh. Hold on. Can you open this? Okay. So now we're gonna make our vodka sauce. Ooh, alcoholic. Let's continue. So now we have our sauce. Now we need to make our meatballs. Also, these meatballs were $8. I should have just bought ground beef and made it myself. But I'm sick, if you can't tell. I'm so sick. Whatever she says. Do you guys listen to Flyleaf or no? Frying up meatballs. Wait, are you supposed to boil them? I actually didn't read the instructions. It only has instructions for tacos? I'm not even joking. The options to make your meatballs are tacos or honey barbecue. How do you actually make the... Oh, it's at the bottom. Sorry. Yeah, you just have to heat it up. Okay. Into the heart pan it goes. I'll show you the heart pan. Isn't it cute? Okay. My lip is getting a bit sweaty from this mustache. It's actually a natural mustache. I'm actually Latina, so I grizz myself. It's natural. I know you're all jealous of me. second question. Can a human get spaghettified? I would say yes. The second question would be, how did a human manage to get that close to a black hole? But let's just pretend you have a magical breathing and life-sustaining apparatus that allows you to get that close. As you get past the Schwarzschild radius, which I'll put the equation for here, you'll experience extreme tidal forces. That equation is here. This tidal acceleration. So, as you experience this, you're of course going to be squeezed and pulled like spaghetti. Like spaghetti. And I don't think humans are meant to be squeezed and pulled, so I think that would be fatal, probably, I would assume. Unless you're that one guy from the Marvelous Four, the Majestic Four, the Fantastic Four, the rubber one. I think he could survive getting spaghettified. Okay, now we're reaching the conclusion of both the cooking and the video. So, let's went over the basic topics. In summary, spaghettification is when an object gets too close to something called a black hole. A black hole is what happens when a star dies, and then all the material explodes in a big event, and then it comes to a very dense point, causing a lot of gravity towards that point. And this gravity is so strong that not even light can escape. So then, when an object gets too close, it experiences something called tidal forces, which is the gravitational difference along this object. So this side of the object isn't getting pulled as much as this side of the object is. So it squeezes in the middle and it stretches out here like spaghetti. In a little bit, I will show you guys the final result. Okay, here is the finished product.
Is this going to be in your video?
Mm-hmm.
Wait, no.